Hey everybody, today we're going to work through Polygons 3. Now we are still dealing with parallelograms, but we're going to talk about three particular kinds of parallelograms that are going to come up a whole lot, and also talk about how to know the difference between them all. So let's get started with the first one, which is a rhombus. Now, you've probably seen this over and over again, and the reality is you probably saw it when you were like 5 years old, and back when you were 5 years old you referred to it as a diamond. But then you get older and you realize, nope, this is actually a rhombus. A rhombus is a parallelogram, all of these today are, with 4 congruent sides. So you will know it is a rhombus if all 4 sides are congruent. Okay. Now, at this point, a lot of people would say, well, I thought that was a square. Well, a square is a rhombus. It is a type of rhombus. So yeah, if you were to draw a square, technically that would count as a rhombus as well. Now, the biggest key to this is that the 4 sides have to be congruent. So it might not look like anything special at all. You know, you might just get this thing and it might just look like a standard parallelogram to you, and it might not really seem like it's any different than any of the others that we've done. But if all 4 sides are congruent, even if it just looks like a regular parallelogram, it is technically a rhombus. All right, now a couple of things that I want to talk about as far as rules for a rhombus, things that you can use as indicators to know that something is a rhombus here. So if a parallelogram is a rhombus, and you might not need both lines for this, you might, it just depends on how big you write, then its diagonals are perpendicular. Now, if you would have drawn it first, I think you would have actually known it without even having to write it, because if you look, you've got this right here and this right here. These are the diagonals. They connect the opposite corners, the opposite vertices here. And what do you know? Take a look. We've got this and this, and they make a right angle. Okay. Now, in a square, you don't necessarily think about it that way, but in a square, that would also be true, because if you were to draw this right here, it doesn't necessarily seem like it right away, but that is definitely a right angle. Now, this third one, I just sketched this one freehand, so I'm not going to guarantee that it's exactly a right angle, but that's a pretty close example of it there. If you drew a rhombus correctly, then it has diagonals that are perpendicular. Okay, so even the one that I sketched is pretty darn close. All right, now, there is another rule that relates to a rhombus as well. And it's going to start the same way as what we just did. If a parallelogram is a rhombus, then each diagonal, so now we're talking about each individual diagonal here, bisects a pair of opposite angles. So essentially what it's saying is that if you are dealing with a rhombus, the diagonals are angle bisectors. So this and this, same measurement. This and this, same measurement. You could even go to the obtuse angle up here, because remember, a rhombus doesn't necessarily have 4 right angles. In fact, oftentimes has two acute angles and then two obtuse angles. So you need to be ready for that. But look at this. We've got this measurement right here and this measurement right here are the same. If a parallelogram is a rhombus, then each diagonal bisects a pair of opposite angles, which means the diagonals of a rhombus are always angle bisectors. So let me complete this picture right here. That looks good. That applies to all of them. Okay, so it applies there, applies there. I won't draw them all, but just another example right here. This angle and this angle are the same. Okay. So that's actually one of the techniques that you can use to know that something is going to be a rhombus. If you are dealing with angle bisectors here, that is a big clue. All right, so let's go to the next one here. And the rectangle you've seen forever. This one is not really new. Instead of having 4 congruent sides, a rectangle is guaranteed to have 4 right angles. Now, the standard drawing of a rectangle, pretty much just like that. I actually want you to draw a couple of them because we're going to illustrate one of the rules here in just a second. But I also want to make sure you know, and you can draw this one really tiny, a square is technically also a rectangle. All right, so what you know is that in a parallelogram, the opposite sides are congruent. You should know that by now. If the opposite sides are congruent and you have 4 right angles, then you are officially dealing with a rectangle. Okay, I'll save the second picture here for a little bit later. But keep in mind, even in the second picture, we do still have 4 right angles. Okay. Now, in a square, if we're looking at the third picture, yes, it actually turns out all 4 sides are congruent and you have 4 right angles. So in a way, it's actually a rhombus and a rectangle, but we're going to get to that here in just a second. All right, let's go over the official rule, the official way that you can actually use the diagonals to know that something happens to be a rectangle. So if a parallelogram is a rectangle, then its diagonals, so we're kind of doing the same thing we did before. If it is a rectangle, then its diagonals are congruent. Now, if you're still writing, you can pause the video for a second, but I just want to go up and show you a picture here. In a rhombus, and I think you can probably see this just by looking at the picture. In a rhombus, the diagonals are not necessarily congruent. If you look at this diagonal, this is very short compared to this. So in a rhombus, there is no guarantee that your diagonals are actually going to be congruent. But in a rectangle, they are. So we're actually going to use the second picture to illustrate that. Our first picture looks fine just the way it is. If you look, these 2 diagonals are congruent to each other. Now, in a parallelogram, we learned back in the past that in a parallelogram, the diagonals bisect each other. So what you actually have here, and this is something that shows up in pictures all the time, what you actually have here is 4 equal pieces. Because if we know that the 2 diagonals are congruent, if we know that this right here and this right here are the same length, and then we also know that they bisect each other, what that basically means is we have 4 equal pieces. So we're going to mark it that way. And you're going to see that a lot. Okay. And that rule also does apply in this other one with a square. You don't necessarily think of it that way. Like, we don't always think of squares as rectangles, but that is definitely the case. All right, now, we are done with the theorems for now. The reason being we are going to the combination of a rectangle and a rhombus, which is, of course, known as a rhomtangle. Okay, that's not true. Please don't ever use that word again. It's a square. Technically, I think it's kind of funny to think about, but technically it is a rhombus and a rectangle. So, I mean, I guess you could be annoying and combine the words, but I guess it wasn't that funny and I won't do it again. Here's the deal. A square meets the qualifications of both, meaning a square is a parallelogram with 4 congruent sides and 4 right angles. So the rules that apply for a rhombus and the rules that apply for a rectangle all apply to a square. That's why you don't have to write any more theorems. So if we go back and look, the first theorem that we did is we found out that if a parallelogram is a rhombus, then its diagonals are perpendicular. Well, if a figure is a square, which, by the way, if you were to look at a drawing of a square, you should see this. You should see that the 4 sides are congruent, and you should see that there are 4 right angles. So the first theorem we did today said that if a figure is a rhombus, then the diagonals are perpendicular. Well, a square is a rhombus, so the diagonals should be perpendicular. All right, now the second rule today said if a parallelogram is a rhombus, then each diagonal bisects a pair of opposite angles. So let's draw that out. If a parallelogram is a rhombus and a square is a rhombus, then each diagonal bisects a pair of opposite angles. So those are equal pieces. Those are equal pieces. Those are equal pieces. And those are equal pieces. And if you do the math, you eventually find out that they are all 45 degrees, but we will get to that some other time. And then the last theorem that we wrote says that if a parallelogram is a rectangle, then its diagonals are congruent. So then if we were to draw the diagonals here and here, then the diagonals would be congruent. So this and this and this and this, all congruent. So long story short, since a square is both a rhombus and a rectangle, all 3 rules that we just did apply to it, as in the first theorem we did, the second theorem we did, the third theorem. A square is all of the above, so all 3 of the rules apply. All right, I hope this helps you on your way. I'll see you next time.